Students, today we'll see the examples under beta lactamase inhibitors. The first one is clavulanic acid, that is otherwise called as clavulanate, and it is available as a potassium salt, and it is isolated from Streptomyces clavuligerris. So this is the structure of clavulanic acid. Before that, already we have seen this is called as penum ring. So what is penum ring? Fusion of beta lactam ring with thiazolidin ring, that is called as penum ring. And this one, no, instead of sulfur we have oxygen, that is called as oxopenum. 1-oxopenum. Oxygen is attached in first position, that's why it is called 1-oxopenum. So what is the structure, what is the basic nucleus present? That is called as oxopenum, and this is a 1-oxopenum. And what is attached in second position? This is called as ethylidene. CH3 CH double bond nano, that can be called as ethylidene. So here by replacing one hydrogen with OH, that is called hydroxyethylidene. So this is the second carbon, that's why it is 2-hydroxyethylidene. So what is attached in second position? 2-hydroxyethylidene, and in third position carboxylic acid group is present. And while comparing with 6-amino penicillinic acid, it is having weak antibacterial activity, that's why it is not used as an antibiotic, and usually it is given in combination with amoxicillin or ticarcillin. Okay, and we'll see the uses of clavulanic acid. They are used in the treatment of septicemia, lower respiratory tract infections and urinary tract infections, bone and joint infections, in skin and soft tissue infection, dental infections, gonorrhea. And we'll see the adverse effects: poor GI tolerance, candidal stomatitis and vaginitis. We'll see the next one, that is called as Sulbactam. So look at the structure. So already we have known the structure for penicillinic acid. Compare this one with this one. So by comparing that, the Sulbactam, no, that is having 2 oxygens in first positions, that's why it is called 1,1-dioxo. First position is having 2 oxygen, that's why 1,1-dioxo penicillinic acid. Already we have known SO2, that is called as sulfone, that's why it is called as penicillinic acid sulfone. So two names it is having, that is 1,1-dioxo penicillinic acid or penicillinic acid sulfone, and it is prepared by partial chemical synthesis from penicillins. While comparing with clavulanic acid, it is 2 to 3 times less potent, and it has weak intrinsic antibacterial activity, and it potentiates the activity of ampicillin and carbonicillin. That's why it is given in combination with ampicillin or carbonicillin. Okay, and we'll see the uses in the treatment of skin infections, tissue infections, intra-abdominal infections and gynecological infections. And we'll see the adverse effects: pain at injection site, thrombophlebitis, rash, and finally diarrhea. Next one is Tazobactam. So look at the structure of Tazobactam, same as that of Sulbactam. So Sulbactam, what happened in the structure of Sulbactam, it is having 2 methyl groups. Here in one methyl, one hydrogen is replaced by 1,2,3 triazole, that is called as Tazobactam. So it is also a penicillinic acid sulfone, and usually it is given in combination with piperacillin in the ratio 1:8, and its pharmacokinetic properties would be similar to piperacillin. And we'll see the uses in the treatment of appendicitis, postpartum endometritis, pelvic inflammatory diseases. And next one is Thienamycin. So look at the structure of Thienamycin. It is coming under carbapenem. First 3 drugs we have seen, no, they are coming under class 1. This is coming under class 2. This is called Thienamycin. So what is the basic nucleus present? That is called as carbapenem. We have known the structure of penum. So in penum we have sulfur in first position. That sulfur is replaced by means of methylene, means that is called as carbapenem, ending with Am. Okay, and if it is having double bond, one double bond, means that is called as carbapenem, ending with Em. And in second position, what is attached? Amino ethyl thioether. So that is attached in second position. And third position we have acid, carboxylic acid. And in sixth position we have 1-hydroxyethyl. So what is the structure of Thienamycin? What is the nucleus present? Carbapenem, Em, ending with Em, and double bond between 2 and 3. And second position we have 2-amino ethyl thioether, and third position we have acid, and sixth position we have 1-hydroxyethyl, and it is isolated from Streptomyces cattleya. Already we said it is a carbapenem that is having double bond, where the double bond is between 2 and 3. So that's why it is called 2-carbapenem, ending with em, otherwise it is called delta to the power 2 carbapenem. So what is the meaning of delta? That is the prefix that is used to indicate double bond, and the position is indicated here, that is 2. So if it is between continuous numbers, we have to write only the first number. So it is between 2 and 3. So continuous numbers, we have to write only the first number. So that's why delta to the power 2 carbapenem. It should end with am, not em. And what is the use of double bond? That is creating ring strain, and that increases the reactivity of beta-lactam to ring opening reactions. And next one, so we have 1-hydroxyethyl in 6 position. No, that is responsible for resistance to lactamases. So next one is called imipenem. So look at that structure. So what is attached? Same as that of thienamycin. Here only NH2 means that is called as thienamycin. So here with the NH2 what is added? CH double bond NH is added. So already we have known this one, no? Here we have known the structure of formamide HCONH2, and in thienamycin that is having NH2. So that one combines with the formamide. So what happens? There may be removal of one molecule of water. How that is going? Here one H, by taking one H from this amine and one oxygen here, one hydrogen here. So one molecule of water is removed. That's why we are getting NHCH double bond NH. Okay. Already we have known R is alkyl, RCO is acyl. So that should end with oil, OYL. Acyl means that should end with OYL. HCO, the parent, no, that is formamide, that is having HCO. So that is also an acyl. So it should end with, already we have known this is a thienamycin derivative, and that is by the addition of formamide only we are getting this one. That's why it should be called as formamidoyl, amidoyl, MAMI, amidoyl thienamycin. But it is in the form of CH double bond NH. Already we have known C double bond N, that is called as imine. So here imine is present. That's why it is called as formamidoyl thienamycin. So what is the chemical name? N-formamidoyl thienamycin. In the case of thienamycin, that is having primary amino group. Here that is replaced by means of non-nucleophilic basic function, and usually it is given in combination with cilastatin. So what is the use of cilastatin? That is an inhibitor of renal dehydropeptidase. Now we'll see the uses. Used in the treatment of infections of skin, tissue, lower respiratory tract, bones and joints, and genitourinary tract, and in the case of septicemia, endocarditis. Next drug is Meropenem. So look at the structure of Meropenem. This is also a carbapenem, but in first position that is having methyl. So it is a 1-methyl carbapenem derivative, and in second position that is added with sulfur, and that sulfur is connected with pyrrolidine group. So that is connected with carbonyl, and that is connected with one amino. How the amino is? Dimethyl amino group. And in third position as usual having carboxylic acid, and in sixth position it is having hydroxyethyl group. What are the uses? The treatment of bacterial meningitis, septicemia, pneumonia and peritonitis. It is given only parenterally. The last drug under that is Biapenem. So look at that structure. Same as that of the carbapenem. Carbapenem nucleus is present. First position it is having methyl, third one acid, and sixth one hydroxyethyl. What is in second position? That is attached with the sulfur. That sulfur is connected with pyrazole. So which pyrazole it is? Tetrahydropyrazole. That one is connected with 1,2,4-triazole. So what is attached with the sulfur? Tetrahydropyrazole 1,2,4-triazole. Why it is called tetrahydro? So in the case of pyrazole there should be 2 bonds. Here that bonds are left. That's why they are called tetrahydropyrazole 1,2,4-triazole is connected with sulfur in second position. So it is a 1-beta-methyl carbapenem derivative. Here the methyl is attached in first position, no, that is in beta configuration. That's why they are indicated as a thick line. That's why it is called 1-beta-methyl carbapenem. Its properties should be same as that of the earlier one, similar to meropenem. That's all about beta-lactamase inhibitors.